For over half a century, one programming language has done it all. It's been a teacher, a workhorse for the very first personal computers, a commercial powerhouse, and, against all odds, an open-source survivor. This is way more than just a tech history. It's a story of ideas, evolution, and just incredible resilience. This is the unlikely story of Pascal.
So let me start with a question for you. What do a super popular data tool like Beyond Compare, some amazing free planetarium software, and the actual code that powered the original Apple Macintosh all have in common? Well, the answer, and this might just surprise you, is the Pascal programming language family.
All right, so let's set the scene. Our story kicks off in the late 1960s, a time when programming was, well, kind of like the Wild West. You had languages like Algol that were trying to bring in some structure, but there was this growing feeling that we needed a tool that didn't just build software, but that actually taught good, clean, and reliable programming habits right from the start.
And that's where this idea of structured programming comes in. In 1970, a computer scientist named Nicholas Wirth created Pascal to be the perfect example of this philosophy. He designed it to be small, really efficient, and to kind of force a level of discipline that would help students write code that was logical and, easy for a human to actually understand.
Now, this isn't just some catchy phrase. It's the actual title of Wirth's hugely influential book from 1975, and it perfectly nails Pascal's whole philosophy. A program isn't just a random list of commands. No, it's a thoughtful combination of logic, that's your algorithms, and the way you organize your information, your data structures. Get those two right, and you've got a solid program.
So Wirth's idea for this orderly, educational language, yeah, it didn't stay in the classroom for long. Not at all. In fact, it grew really fast, becoming a central pillar of the computing world for more than a decade.
Just look at this timeline. Throughout the 70s, it completely took over universities as the language for teaching computer science. Then Apple brought it to the masses with Apple Pascal for the Apple II. It was even used to build the operating systems for these incredibly powerful Apollo workstations, and, this is the big one, it was used to write huge chunks of the software for the Apple Lisa and the legendary original Macintosh.
So why was it so successful? Well, it really boiled down to a couple of key things. Its strict rules, what we call strong typing, meant you made fewer silly errors, and its clean, almost English-like syntax made it so much easier to read and learn. That combination right there made programming more reliable and accessible, and it empowered a whole generation of developers who were literally building the software that kicked off the PC revolution.
But you know how it is. The world of software never ever stands still. A whole new way of thinking was coming. Object-oriented programming, or OOP. It was a new way to build massive, complex applications, and Pascal had a choice: adapt or risk getting left behind. And that moment right there caused the language to branch out into two major new directions.
Okay, look at this. On the left, you've got that simple, classic, straight-to-the-point Pascal. But on the right, you see that new class keyword? That's the heart of Object Pascal. It let developers bundle their data and their functions together into these things called objects. It was a structure that was absolutely essential for building the fancy graphical apps that were about to define the next era of computing.
So you've got these two major players driving this evolution. Over at Apple, you have Larry Tesler working with Nicholas Wirth himself to create Object Pascal for their Mac app framework. At the same time, over at a company called Borland, this brilliant engineer named Anders Hagelsberg, who, by the way, would later go on to design C# at Microsoft, he added object orientation to their super popular Turbo Pascal. And that move laid the groundwork for what would become the development powerhouse, Delphi.
But even with all this innovation, Pascal started to face some serious heat from languages like C++. By the early 90s, Borland was shifting its focus to Windows, and honestly, it looked like Pascal's story might be coming to an end. But then, something pretty amazing happened: a grassroots, community-driven revival.
Here's how it all went down. When Borland stopped making its DOS compiler, it left this big hole in the market. A German student named Florian Klampfel just decided to fill it himself by starting his own compiler from scratch. Now get this, within 2 years he hit this critical milestone where the compiler was good enough to compile its own source code. That's called self-hosting, and it's a huge deal for a compiler. He then put it online, and a global community of developers just jumped in to help, porting it to new systems and keeping the language not just alive, but actually thriving. And the result of all that community effort? It's just staggering. Free Pascal really lives up to this idea of write once, compile anywhere. I mean, this table here just scratches the surface. It can target everything from the Intel chips in your PC to the ARM chips in your phone, all the way to old PowerPC Macs and even modern WebAssembly, so you can run it in a browser. It's incredible.
So this long, winding journey from academic project to commercial success to open source survivor has created this surprisingly wide, diverse, and modern ecosystem for a language that's over half a century old. It's pretty wild when you think about it.
In fact, there's a really good chance you're using software built with Pascal and you don't even know it. A lot of popular, modern tools like the File Archiver pzip, the Game Utility Cheat Engine, and the File Manager Double Commander, they're all built using free Pascal and its open source IDE, Lazarus. It's like this hidden giant, powering tools that millions of people use every single day.
So today, Pascal really exists in two powerful forms. You've got the commercial enterprise-grade strength of Delphi, and you've got the incredible versatility and total freedom of the open-source Free Pascal and Lazarus project. Together, they offer a complete, modern toolset for building pretty much anything on almost any platform you can imagine.
And that kind of brings us to our final thought. The story of Pascal is so much more than a timeline of technical features. It's a testament to the power of a really good idea, and maybe more importantly, the power of a dedicated community to keep that idea alive. It really makes you wonder, in a tech world that's always chasing the next new shiny thing, what can we all learn from a language that has managed to survive, adapt, and thrive for 50 years?